Okay, so on the first one, I have graph the function y equals natural log of x plus 3. Okay, so I'm just going to start by graphing the regular natural log of x, and then I'm going to shift it to the, well, this, since it's grouped in here with the x, that's a left-right shift. So this is going to the left 3 units. Okay, so let's graph our regular natural log x function. So the regular natural log x function has an asymptote here at x equals 0. It goes through the point 1, 0, and then 2, 3, and when you get to e, it goes up to 1. Okay, and then it has an asymptote going down like that. And so what I'm going to do is I'm going to shift all of that left 3 units. So if I shift that asymptote left 3 units, 1, 2, 3, my asymptote is happening now at -3, and my graph is going through this point, shifts left 3 units, 1, 2, 3, and so then, and also this is going to shift left 3 units, so 1, 2, 3, and so my new graph is going to look like that. Then it state the domain and range and asymptotes of the function. So the domain, so now all the x values that are where we have graph, the graph is kind of starting at x equal -3, but it doesn't actually hit -3, so -3 to infinity with an open parentheses. Range is going to be, it's going to hit all the y values from -infinity to infinity, and then the asymptote happens at x equal -3 now, instead of x equals 0, because I've shifted everything to the left 3 units. Alright, so the next one, I'm looking for matching statements A through, well, they're only 3, so it's A through C, actually. It's not a big deal, to these functions. Okay, so then, so the first one I want to look at is the limit as x goes to infinity. So I'm looking at this portion of the graph as x goes to -infinity. What's happening to my y values of my graph? Okay, so if I look at this graph, there's no graph here as x goes to infinity, so it can't be that one. If I look at this one, as x goes to -infinity, my y values are getting more negative. So that's not working. And this one, as x goes to -infinity, my y values are getting closer and closer to 0. That's what I want. I want that as x goes to -infinity, my function gets closer to 0. So this is graph 3. Okay. For the next one, I want to say as x goes to 0 from the left. So I'm looking, as x goes to 0 from the left, I'm looking at this part of my graph. So as x goes to 0 from the left, again, first this one has no graph coming in to 0 from the left, so it can't be that one. This one, as x goes to 0 from the left, my function is going up to positive infinity, which is what we're looking for. So this is graph 2. But let's look at this last one. As x goes to 0 from the left, it looks like it's approaching maybe 1 or something. So, so it's not that one. Okay. Last one. It says I'm looking for what happens as x goes to 0 from the right. So I'm looking this thing as I'm going to 0 from the right-hand side. Should be approaching -infinity. So if I look at this function, as x goes to 0 from the right, this function's going down to -infinity. So that's the right answer. But let's look at the others. This one has no graph there as I'm coming in to the right. And this one, as I'm coming into 0 from the right side, it looks like it's approaching 1, say. So the correct answer is graph 1. Okay, next one, it says that the point -2, 5 lies on the graph of f. What point lies on the graph of that thing? Oh dear. Okay, so let's think about all the transformations that are happening here. So this is a flip about the x-axis. And this is a shift left by 2 units, and then this goes down 7. Okay, so let's start with our point negative 2, 5, and then we'll do all these transformations to it. So here we go, negative 2, 5. Okay, so there's my original point. Okay, first thing I'm going to do is I'm going to flip it about the x-axis. So then it's going to go to there. So now it's at 2, negative 5. Wait, oh, I didn't do quite enough. There we go. 2, negative 5, or negative 2, negative 5. And then I'm going to go left 2 units. 1, 2. So that's over here. And then I'm going to go down 7 units. Okay, so 5, as I'm already at negative 5, I'm going to go down to 1, 2, 3, 4, 5, 6, 7. Okay. So I took my point, I flipped it about the x-axis here, and then I went left 2, and then I went down 7. And so what are the coordinates of my point here? So I could see that the x-coordinate of my point is going to be negative 4, and the y-coordinate of my point is going to be, let's see, I was at negative 5, and then I went down 7, so it should be negative 12. Okay. Then it says show that the function, so that's the point. So it's going to be negative 4, negative 12. Show that the function is even, odd, or neither. Okay, so to determine if a function is even, odd, or neither, I want to start by plugging in negative x. So let's see what f of negative x is. So I'm going to get square root of negative x squared plus 1. Well, when I square a negative, it's just the same as the positive. So square root of x squared plus 1, which is equal to my original function. So if f of x is equal to f of negative x, then that is even. If I had got that f of negative x was equal to the negative of f of x, it would be odd. And if I got something that was neither of those things, it would be neither. Okay. On 22, it says the point 39 is on the graph of f. Let's put that on there. There we go. What other point is guaranteed to be on the graph if f is even? Oops, I switched around there. So if f is even, then that means that it's reflected about the x-axis or the y-axis here. And so if it's even, then this point is also on there, which is negative 3, 9. So the answer for A is negative 3, 9. And if it's odd, then that means it's negative x, negative y is on the graph. So that's down here. So this point would be on it if it were odd, because it's symmetric about the origin. So that's negative 3, negative 9. Okay. And then I want to determine if the function is even, odd, or neither. So I think, to me, I feel like it's easiest to just graph it and see what we have here. Let's plot all these points here. Okay, so we have 0, 0. Okay, that's easy. Then we have 1, 3. Oh, we're going to have a lot of points here, so maybe I'm not going to be able to do it exactly like that. But we'll have 1, 3, and negative 1, negative 3. Okay, so it's looking like it might be odd at first glance, but let's see. We have 2, 12, and negative 2, negative 12. Okay, still looking like it could be odd. Last one, 3, 33. and negative 3, negative 33. Okay. So this, since we can kind of pair up each of these guys, and I can see that f of negative x is equal to the negative of f of x. We can see also it's symmetric about the origin. So since that's true, this is an odd function.